so that it can what? Expedite development. Any question here so far? This is the OSI layer model. There are 7 layers. We have 7 layers. Starting from the bottom, we have physical layer. That's layer 1. We have physical layer. That's the layer 1. We have data link layer. That's the layer 2. We have network layer, layer 3. Transport layer, layer 4. Session layer, layer 5. Presentation layer, layer 6. And application layer, layer 7. In order to remember the layers, you cannot mix them. People have a funny way to remember it, and one of them is all people seem to need data processing. All people seem to need data processing. The A stands for application, P stands for presentation, S for session, T for transport, N for network, D for data link layer, and then P for what? Physical layer. So this is how the OSI reference model looks like. We start the layers from the bottom. Physical layer, layer 1, layer 2, layer 3, layer 4, layer 5, layer 6, layer 7. But if you want to write it, we have to write it application layer, presentation layer, session layer, transport layer, network layer, data link layer, physical link layer. But the 1, 2, 3 start from the bottom. So note, if we ask you which layer is layer 7, you don't count from the top and come and land on the bottom and say layer 7 is physical layer. You'll be wrong. Layer 7 is application layer, even though it's at the top. Presentation layer is layer 6, even though it's second from the top. It's like that till you end at physical layer. These have their specific functions. When you are on the network, these layers that we are talking about, every day we use it. So long as we communicate using our communication gadgets. So for instance, the application layer. Like I said, the application layer provides a user interface. The application layer, that's the layer 7. It provides a user interface. All of us have been on the internet before. And when you are on the internet, you have an application that you are interacting with. So that is what we call application layer. Then we have presentation layer. That is the second from the top, layer 6. What does presentation layer do? As the name tells, presentation layer presents data. It presents what? Data. It can handle processing such as encryption. When we talk about encryption, You see that when you send data on WhatsApp, WhatsApp can promise you that they are going to encrypt the data, meaning that they are going to scramble the data such that anyone who happens to intercept the data cannot read or make meaning out of it. Instead, the data can only leave the source and can only be read by the one it is destined to. WhatsApp can assure you that when you send your message, it's safe until it reaches the destination. Then we also have the session layer. That's layer 5. Session layer, what it does is that it keeps different applications separate from the other. You see that if you open your computer, sometimes on your browser, you can open WhatsApp, you can open Instagram, you can open Gmail, you can open about 4 or 5 applications at a time. And maybe you are communicating with your friend using WhatsApp. That's why it's open. You have opened an email to read your emails or send email to someone else. If, for instance, I reply your email, why is it that my message will not come and appear in WhatsApp? I'm communicating with you via email. But as we are communicating via email, someone else is communicating with you on WhatsApp, on Facebook, or Instagram. Why is it that when I reply you the email, it won't go and appear at WhatsApp? You see, it won't appear at WhatsApp. There is something in the machine that makes sure that the email messages only appears at the email. The WhatsApp messages only appears if and only if WhatsApp is open and working. But they cannot, one message will not go and appear in the other one. What ensures that is session layer or layer 5. It's layer 5 that ensures that every message appears in the application that is meant for and not the other. So, and we have transport layer. What does the transport layer do? The transport layer provides reliable or unreliable data delivery. It will do the transport layer. Can't you see that when you are going to travel, you have a means of transport? So when you send a message, ordinarily when you are sending a parcel, you either put it on a bicycle to travel from the source to the end, or you put it in a car, or you give it to someone to walk, or you give it DHL, anything, you can give it out. Transport layer. It will be transported from wherever you are to wherever you want the parcel to go to. So the same way, when you have data to deliver, the data will leave your end and it has to be transported. But remember that transportation can be reliable or unreliable. It's not true that you can enter a bus to go to Volga from Kumasi, and along the way, the bus can stop. It's spoiled. May God forbid, the bus can get accident. something can happen such that your traveling will be unsuccessful. So it's similar. When you send data from the source to the destination, anything can happen. The data may be delivered successfully or unsuccessfully. That is why we are saying that the transport layer provides reliable or unreliable data delivery, because the data may not get there. This same transport layer, it can also perform error correction before retransmission. Granted that you send the message. Remember, in year one, we did things like bitrate, error checking, where when you send 5 bits, 11111, and the destination, the receiver receives it at 10111. You see that 1 bit has changed from 1 to 0, telling you that there's a problem. So this transport layer does the error correction. So it will correct and then do what? Retransmit. If it finds out that the data that is sent, there's an error in it, it will do what? It will perform the what? Error correction before it will what? Retransmit. That's the transport layer. We also have the next, which is what? Network layer. That's layer 3. You see, the network layer, it will provide logical addressing. And that's what routers use to determine the path that packet should take. The network layer, that's layer 3. The layer 3 provides logical addressing and determines the path through which data should go. So that if you are sending data, this data is, say, your brother in Accra, who is, say, in Lagos. You have your family, say, in Tamale. You have another friend, say, in the US. And you are communicating with all of them. When the data leaves your computer and you say send, you realize that the data meant for US will get to the US. The data meant for the Legon guy will get there. And the Legon, the data meant for the Tamale family member, it will get there. Why? It is because there's what you call a network layer that provides different addressing to the data you are sending. So such that, just like there are many houses, if you want to come to my house, for instance, I must give you my house address. I must give you my house address in Tamale. I must give you my house address in Kumasi before you are able to locate my house. Meanwhile, in my area, there are many houses. So who does this? It is the network layer that will make sure that it gives every house, and for that matter, every computer, a different address, such that your data, when it leaves your computer, it will go where? It will go exactly to the machine of your brother in the US. It will go to the computer of your mother in your house in Takoradi. It is the network layer that does that. Then we have the data link layer. This data link layer, what does it do? The data link layer will combine packets, data packets. It will combine the data packets into bytes. And the bytes will be combined to form what you call frames. Data link layer, what is its function? The function is of the data link layer. It will combine your data that you are sending from the application layer. The application layer, you send the data. It went through the presentation layer where it did encryption. Then the session made sure that if you are on WhatsApp, you are on WhatsApp forever. If you are on Facebook, you are on Facebook forever. If you are on Gmail, you are on Gmail forever. The transport layer, it does reliable and unreliable what? Data transmission or data delivery, and also performs what? Error correction. Should there be a problem, then when it does the error correction, it will retransmit. That's the transport layer. Then we also talked about the network layer, where we say that it is the network layer that will give us or provide us logical addressing to say that machine A has this address, machine B has this address, machine C has that address. And it is this routers used to direct packets from the source to the destination. So when we talk about a router works at layer 3. Routers work at layer 3. And we are now on, let's say, data link layer. We are saying that the data link layer will combine packets. The data that you send is going to be in the form of data packets. When you send a message, by the time it reaches the data link, it will put them, it will chunk them, it will partition them, break the message into what? Data packets. And the data packets will be combined to form bytes, and the bytes will also be combined into what? Frames. Who does that? That is the what? Data link layer. And it also provides access to the media. What media are we talking about? We are going to use wireless link, fiber link, Ethernet link, coaxial link. The type of cable you use, the data link will start preparing your data to pass through that link. So that's why I would say that it provides access to media using the what? MAC address. Media access control address. This MAC address also performs error detection, but it doesn't do correction. Data link will have error detection, but it doesn't do correction. Remember at the transport layer, we said the transport layer will perform what? Error correction. At the data link layer, it will perform what? Error detection. It will detect the error, but it cannot correct the error. That's the difference. The data link layer will detect error, but not correct it. But transport layer will correct error when it's detected. Then we have the physical layer. What does the physical layer do? The physical layer, by the time your data reaches there, the frames will turn to bits. We did bits last semester. The 0 bit, the 1 bit, a combination of zeros and ones. So your message that travel all the way from application, all through to network. At network, it turns itself to what? Data packets. Then it went to data link layer and turned itself from data packets to what? To byte, and from bytes to frame. And now at the physical layer, the frames will now change to bits. So it is the physical layer that will move the bits between the devices. So it is at this stage that we specify voltages, because the bits are going to be in the form of voltages. The wire speed. So we say that your data, when you are using fiber optic cable, will be faster than when you are using, say, Ethernet cable or coaxial cable. The physical link or layer will turn your frames into bits and pass these bits through the wires. Through the wires that you are using. If you are using what? Fiber optic cable, then it passes through there. If you are using coaxial cable, the bits will pass through in the form of what? Voltages. If it is optical, it will go through in the form of what? Light. So that is the OSI layer. The OSI layer, we have 7 of them, and that is what we have discussed. Now, this same OSI layer, look at the OSI layer, which I've now colored into 3. Why? The 7 layers are now put into 3 categories. The 3 categories are coming because they perform 3 functions. They perform 3 functions. We have the upper layer, which is red. The middle layers, that's the green. And the bottom layers, that is the blue. The upper layers will communicate with the user interface. So the upper layer, that is application layer, presentation layer, session layer, will communicate with the what? User interface, or say the application that you are interacting with. If you are on a computer, you are interacting with Gmail. The Gmail is working within these 3 layers. If you are using Facebook on your computer or your phone, the phone works within, the application works within these 3 layers. That is to say, it will work in the application layer, the presentation layer, as well as the session layer. Your application works just within these 3 layers. Then we have the middle layers. What are their functions, or what is their main function? They do the reliable communication and routing to a remote area or remote network. We earlier said that the transport layer will do reliable and unreliable delivery of data. And the network will do what? It will route the packet. It will show your packet where to pass. Pass through Accra Road, pass through Tamale Road, pass through US Road. It is the network layer that does that. So the middle layer will do reliable communication and routing. Reliable communication and what? Routing. Directing your data to the area it's supposed to go to. Then we have the bottom layers. The bottom layer, what does it do? It communicates to the local network. It communicates to the local network in that if your data leaves your machine, the next moment it's going to do is to transmit your data to the next available machine. The machine will call it. You see, it's not only computers that communicate on the network or internet. It's not just computers. We have things like routers, switches, or routing switches. So in general, we just give a general name, a generic name, and we'll call it a node. We'll call it node. So when I say a network node or communication node, you can put computer as part of the network node. If it is a router, it can also be a router. So in order not to say that we are talking about a computer or a router, any device that can communicate, it qualifies to become a node. So the data link and physical layer, they connect directly to the next neighbor node. So if you are in your room and you want to communicate with someone, or if you are saying KUST network and want to communicate with someone in Legon, your machine cannot just travel from your table straight to Legon. No. Especially when you are using KUST network. It has to leave your computer and go to the nearest wireless router. And that router will take it further to KUST routing switch, main routing switch. Before the routing switch will take it out of KUST network system. So the data and the physical layer, we are talking about the direct connection. When the message leaves your computer, where will it go next? The next available machine or node it will hit before it also transmits your data to some other point, then to other point, to another point. It will go like that till it reaches the destination. So it is the data link that does what? That is responsible to deliver the message from your machine to the immediate neighbor. That is what we are talking about. So here is it. The upper layers of the OSI layer, that is the red, communicates with the user interface and application. The middle layers, they do reliable communication and routing to a remote network. And the bottom layers communicate to the local network. So we have basically talked about the OSI layer. At this point, we have exhausted OSI layer. Remember, initially I said OSI layer and TCP IP model. We are going to compare and contrast the two of them. So with what we have talked about so far, we've just been on the OSI layer. Now, there are two ways. Either we continue with the TCP IP or we stop and continue tomorrow. Which one do you prefer? Someone who wants to talk can raise their hand. I'll unmute you and you can talk.
Which I think we can continue tomorrow.
We can also talk.
I think you can continue tomorrow. Yeah, tomorrow.
We can continue tomorrow.
Yeah.
Okay, that's what Regan said. But Regan, do you actually understand what we have discussed? You are still on the floor, Regan. Regan, do you understand what we have discussed?
Yes.
Okay.
All right.
So I agree with you because I think the numbers are not many people have come. So if we cover a lot, they will miss a lot too. So I'm not able to call some people names because I see something like their names don't show. So I want names to show. I want to call names. I don't want to call just anyhow a person. Asamoah Clinton. Asamoah Clinton also.
Sir.
Yes, I'm listening.
I'm here. So I think it's very clear. We understand everything. And I think it's a very good lecture. I think tomorrow we don't have class early in the morning. I think till 2. So we can have a longer period so that we can continue if there is anything else.
Okay, that's fine. And you will also realize that, Clinton, you will also realize that, as usual, what we have discussed is not in the slides that you have.
Yeah, like explaining the OC models, like understanding
it's
is
not
better.
there.
Most of them are not.
So sometimes I add things in my lecture. So, but you have to keep reminding me so that I'll give you the latest material. Okay, Asamoah Clinton, that's fine. Anyone wants to talk again? Cyril. I see some name called Cyril. Is that a person's name? Cyril, can you talk? Okay, Cyril doesn't want to talk. Adolf Osu Kwabena, unmute yourself. Adolf Osu. No, any lady. Aqua Kelvin. Is Aqua Kelvin there?
Yes, please.
Okay, talk. Is that Aqua Kelvin?
Yes, sir.
Okay, Aqua Kelvin, how is the lecture?
Sir, fine. The understanding was great. You explained it so well.
Okay, thank you. So, do you also accept that we should break so that those who have not joined can be able to join tomorrow? Hello? Okay. I think there's a lady, Benedicta. Benedicta, I want you to talk. Is Benedicta a female name?
Yes, sir.
Hey, okay, Benedicta.
Yes, sir, please. It was really great. I understood everything. And God bless you.
Thank you so much. So with Benedicta's message, we'll end today's class. But I'm at home for a workshop. I will check what time will be available with the class rep so that we can meet tomorrow. So that small, we can cover up. If we do big, people will lose the understanding. So on this note, have a good evening and bye-bye.